Now then, so if you remember a few weeks ago I took a small 12 volt turbine, wind turbine apart, found we got problems with the bearings etc. So this is part 2, and this is where, without wanting to spoil things, it gets put back together. So hopefully you enjoy this. Let's crack on. Right, that'll do. We'll just let that dry, harden up. It's just an insurance policy. So I'll get back to you when this lot's dried and I'm ready to put everything back together. Right, I'm just going to clean these threads up because as you can see down here they're all gummed up and we want this to be real tight, so I'm going to clean those up with my safety glasses on. Right, that's better. I think now we can put the bearings in the housing, and then we can put this in, and then we can see if the stator, the varnish has dried. We can put that back together. We're on a roll. Okay, I'm just going to warm that up gently, nothing too much because I don't want to damage the paint. Okay, so we decided to put this tin seal in there. Now we need the spacer. Where's my box of bits? There's a spacer. There we go. Perfect. Yeah, that's quite warm. That just helps expand everything. So we'll let that cool down and then we can put the rotor in there. Ha! I heard you. I heard you. You thought I'd forgotten. So let's just pop this on. In. There we go. That's in there. Okay, here we go. Now with these magnets, just got to make sure that there's no bits sticking to them, bits of steel or what have you, that will create a nuisance later on. I think there's a reasonably good air gap between the magnets and the stator. There we go. Excellent. Now we put the stator on there. Here's the problem. The finger snapping problem. I wonder, should it be better to put the stator in first? line up these notches here. There's a notch there. You see it lines up with the hole. I think this might be better. And what I'm going to do is I'm going to put that. I'm just a bit Did you see that? But at least it's together now. Right. Bit fiddly, but it's spinning freely now. We should actually get voltage off there. Let's find the multimeter. Right. Between that one and that one. What are we on? Well, there's a bit of voltage. Okay. I'm checking each phase. That's it. Yep. And then it is that one and that one. Let's just put it down to 20. Yeah, well, at least there's continuity there. We better just check to see if there's any short. Oh. They're all the same. So there's quite high resistance. That will do. Well, we can start putting this back together even further. That's amazing. We've got the body here, and I just thought I'd just give those slip rings a bit of a clean up. If they've got a bit of resistance on them, then at lower voltages and currents it might create a problem. They're brightening up, which is good. Of course, on the Proven, everything's a lot beefier, and instead of just one brush per slip ring, there are two in a sort of jaw arrangement with a spring between them, so they're clamping on. That's 48 volt, that Proven, you know, and it will give at least 30 amps. So it's not really a 2.5 kilowatt unless you're in an absolute storming gale, which is about par for the course. That's better. That's a lot better. You know, this has been sat on the top of a tower for quite a long time. not actually working. Now what we've got to do is those 3 wires have got to go down there. Okay, so I think we need this the other way round, and then we can put a block of wood over here to support this. So put that round there like that. That needs to support there. Find something. Okay, so that's supported. Now we have to find the little bolts. So these are they. And this is going to be a bit tricky, because they have to go from underneath. So we put the bolt through. Ah! Did you hear that? Yeah. Finally, I got that sorted. Let's just have a look. There we go. And as you see, the connections are on the bottom, because they're actually, that's where the connection to the brush is, so you can't do it really on the top. Okay, now I just want to make sure we've got connections between these. We're on continuity. Between that one and that one is, we got something. Between that one and that one we've got nothing. Between that one and that one we've got nothing. That's not right. And I really don't like this at all. There's a circlip in there. And we've got a bearing. I wonder if we remove that circlip, whether or not that shaft will come out. I doubt it, but let's try it, because it's really difficult to get to that lot. Okay, well that was a struggle. That's the tower stub, and as you can see there, there's a circlip groove, and we finally got the circlip out. But it was a struggle, mainly to get that circlip out. So then I was able to belt it there and get the stub out. Yeah, I've got this all wrong. Trying to do this upside down was next to impossible. I suppose you want to see what I've done. And this is what happens when you try and do it blind. Focus. See? So now we can do it properly. Yeah, it's not as if there is some those tails to the brushes are fixed in any way, and you can't see. So I'm just going to sort that one out. So there we go. That's all lined out now. So I'll put that back together. I'll put that spigot back in the bottom there, and you just see the brushes here, sprung loaded. So when I put this back together, I'll have to be careful when I'm putting that shaft in that I don't damage these brushes. So that just drops in there like that. Good. So we've got to remember to put that in. I think that one's cleaning up first. Right, let's see how we get on. That goes through there. Then we put the circlip on, and then we start to depress the brushes. Okay. Yeah, good. Good. I'm getting there. Yeah. Whoop. Nearly there. I think we're there. That's good. Yeah, and then we put the circlip back in. I'll just give you an overhead view of that before I do that. There. So that's all back in now, and we can just about, you can see the 3 brushes down the bottom there, all in line. Champion. There we go. Excellent. That was a bit of a struggle. Maybe I should have taken that out when at the first disassembly. But you've got to work out how things are put together. Right, this lot can go back in now. So that I think we'll have the wires wrapped around like that. That looks about right. Ah, what have we forgotten? The O-ring. Luckily, it can go stretch over. There's no actual seating for this. I think it just sits like that. Or perhaps we put it over there like that. That's a bit better. And then we wrap those wires round like that. And we line that up with that. Okay, and then get the screws in. Okay, so what diameter is that? 17 mil, 16.98. Okay, so then we've got the blade boss here. Are we still in shot? Yes, we are. Zero that out. 16.75, 16.8. We're reading it upside down. Right, I wonder if a bit of beer tin or something will do. Get a narrow strip of that. That might just shim that out a bit. That boss is about 20 mil deep. And that area there will push on the bearing. I don't really like that. It's a bit ridgy. It could quite damage the bearing seal. So we could do with a washer there or something. Yeah, not really over keen on that. That there. There's a sharp edge there, and then there's a dip, and then there's another, well, you wouldn't call it a sharp edge, but it's another bit standing up, ideal for cutting into bearing seals. Although it's right behind there, but you can guarantee the weather will get in there. But if we wanted a little bit of something to push on that bearing, it would have to be quite narrow. So what I'm trying to do here is, if you imagine that is the shaft and this is the rotor with the magnets, one bearing goes on there, then you put a spacer on, then the other bearing goes on, and I'm trying to put a spacer on there so that when the nut does up, it pushes, it locks all the inner racers into this shaft. So it's not the friction fit that stops the inner race from turning round, it's the fact that it's all compressed from there through the inner race, through the spacer, through the inner race, through the spacer, and there's the hub, and it locks them all together tight. So previously, when this turbine had been put together, the end nut wasn't tight enough, so that meant that the bearings could spin on the shaft because it wasn't locked tight. Might have to make something, but it'd only be, well, I suppose it could be quite, so it would be 17 mil on the inside and 22 mil on the outside. Of course, you know what would be ideal, but we won't be able to cut it, would be a bearing race. Knock the middle out of a bearing and then slice a bit off, but we can't slice it unless we use an angle grinder, and then it won't be very accurate. And it only wants to be a couple of mil thick. Not very entertaining, that. But let's put this on and just yeah, we need to definitely need to shim that out. It's been doing this all the time. Yeah. And then it wants to press hard against that inner bearing race. Okay. Leave that with me. We shall find some way of doing something. Right. What have we got here? I took the ball race that was worn, and split the outside and took the middle track and put it in the outside vise and cut it down with the thin blade on the 4.5 inch angle grinder, and then just trimmed it up a bit. That'll be right. That'll do. So we need to find a beer can or something like that, something reasonable thickness, to make a little shim to go round there. Right, got a little thin bit of shim here. It's about 25.25 of a mil thick. So let's just pop that in there. A little bit more off the edge. We don't want it overlapping. Okay. Now, whoops. Some sort of spring loading effect going on there. There, that's a bit better. So that spring loading effect is obviously the magnets pushing down and they're pushing back. Bit of copper slip on there. Now I had the Allen key only a moment ago. Here it is. Oh, that's a lot better. That's the flex in the blade. Give it loads of welly. Yeah, perfect. Right. I think the only thing to do is to... This is 3-phase output. So bring a wire down, and I've got a 3-phase rectifier, and attach it to a battery and wait for the wind to blow. So we need a piece of scaffolding tube or something in a fairly safe place that nobody's going to walk into it. Okay, that's that back together. I don't see any further problems. It's shimmed out. We've got full pressure down through those bearings so that all of the inner racers and the spacer and the magnets, the rotor, are all clamped together really tight. That's brilliant, and it's quite free. I bet you the general rule of thumb is, here, let me talk to you. The general rule of thumb with turbines is, and we noticed this in the past, if you fix a turbine and it's a good fix, then you don't get any wind for 3 weeks. So we'll wait and see. This is just a test of that turbine. There it is. It's not very high and we're in a bit of a shadow area. But I've just got an AC, the 3 phases coming down this cable, and I was just checking what the voltage was. Now I know that when you put a rectifier on there and you put a battery, the rectified voltage will go up, so we just got to be aware of that before we start. Let's just go and have a look at the meter on the AC side. So we're on 20 volts AC. Well, we're getting something. Can you see that? You probably want that the right way around. I think it has to whiz. No, you can't see that. So the turbine's just, it's in turbulence at the moment. We're on volts AC. That's between one phase. That's another phase. And that's another phase. I mean, it's not the ideal place for be testing a turbine. You want to be out amongst away from all this lot. But when the blade starts to make a slight noise, we will get up to 14 volts. But we might have to wait for that. Can you hear that? The blades are just starting to make a noise. Anyway, we'll put the rectifier on there and see what happens. I've tested the rectifier, so there doesn't seem to be a problem with it. And here it is. So DC out, 3 phases in. Okay, so I've got the output of the rectifier connected to this battery. It's just a small load, and the battery at the moment showing 12.76. Hopefully you can see that. So theoretically, at some point, this battery will create a load on that turbine when the turbine voltage gets up to charging voltage. And of course the turbine voltage at the moment well, 3.5 volts. I think it's when the blades start making a bit of a noise we start getting a charge. But it's not the, as I said earlier, it's not the ideal position. But there you go. And at least we know all 3 phases are the same. And it has the potential to charge. I know the wind's in the camera, I know. But there you go. Just, yeah, the position's all wrong. If we were sort of on the edge of the west coast of Scotland or in Antarctica, it'd be going like mad. So there you go, that's another item that's been fixed. It can go back to its owner now, and hopefully it will continue to generate and supplement a solar system. You know, it's, where are we, August now, start of September, so by the time we get through to November, that turbine should be making a considerable difference. Short days, you know, not so much sun, and the turbine does help. Hopefully you've enjoyed this. Please do the old YouTube stuff, you know, like, subscribe, all that lot, and I will catch up with you soon. Cheers for now.